Hey Andrew,
Good morning.
good morning.
We are
Morning.
already live.
Wait,
uh,
what?
so I'm live streaming on YouTube at the same time. There's a
Oh,
bit of a delay. So that's why I can't have my video open on Zoom because it's like not letting me use my video in two apps at once.
oh, so if we go to YouTube, we can see you?
Yes, technically.
Interesting. Interesting.
I'll put the YouTube link as well. I'm gonna figure this out slowly. I feel like such a zoomer. Or not a zoomer, boomer. I was like trying to set this up and I was like, where are all the
Is this
buttons?
like
Or
a premium account like feature? Like you can stream on YouTube or like a free account can also do the same?
free account. Free account.
Oh,
Yeah. Yeah, so you could go and uh, stream too.
well, one day when I
One
have
day.
a need.
Yeah. Um, let's see.
Oh,
All
interesting.
right. Um, yeah, I was going through y'all's practice question answers. They all look good to me.
Nice.
I think, let's see. The delegation one's good. Is kind of hard. So.
Yeah, I feel like we decided kind of just like let you take it whenever you get there. We have our own interpretations, and then yeah, because I feel like we just approach it from like different angles.
Yes. Yeah, that's totally fair. Let's see. Okay. All right. Yeah. So I think for first part of this is going to be a review for for the people on Zoom.
Yeah,
But figured might as well start from scratch with the first question again. I
yeah.
just have the weird. I can never figure out Markdown either. All right. I'm gonna have to edit out all of this chit chat later too. um. All right. So, okay, I can see the YouTube live chat. So, for anyone in there who does have questions as I go, feel free to just chat them in. Um, cool. All right. So, practice questions. I think there are 10 in here, like 10 main ones. There's a bunch of bonus ones. I think some of the bonus ones even I would struggle with for a little bit, um, or a lot of it. We'll find out. So, don't feel bad if any of the bonus anyone gets stuck. Um, We'll start with the easiest, which is basically transactions versus the traces table. Let's go to Dune. I was trying to play with the V2 engine, but I think they're still figuring some stuff out. So we're gonna stay on V1 for now, and then we'll probably revisit V2 in like a couple weeks, I would say. Just because some of the functions that we use, such as like byte and numeric, don't work on Spark SQL. So we're gonna have to come back to that. All right. Let's just get started with the easiest. Yeah, let me look at that actually. So hopefully, if you are here, you've done some sort of wallet transaction before. So you've at least seen like Etherscan, right? So like if I take any of these transaction hashes, and just as a reminder, every transaction has its own unique hash, and they shouldn't repeat, or it's a very low probability of repeating. Um, this would actually be, I think this one that I took is like the very first ETH transaction, all the way back in 2015. But even here, you can see there's transaction hash, there's a block that it occurred at, there's a from address who is the signer, and then there's a to address who's the receiver. There's some sort of ETH value, some sort of gas fee, and we won't go into gas price and whatnot yet. Um, but the important part is just kind of getting familiar with like, okay, I can see the stuff on Etherscan. I can see the exact same data here in Dune. The only thing you'll notice is that Dune uses like a slash x instead of a zero x, which has to do with like how Postgres stores like byte A data, right? So if you're not familiar with SQL, If you're not familiar with SQL, basically all of these addresses and whatnot, hashes, I guess, they look like strings, but they're technically not strings in the database. So that's something that I think takes some people a bit of time to get used to. Of like, oh, I want to do something with this string, but like I can't, or like I want to convert it to a number and I can't figure it out and whatnot, right? So we'll get into that, but for now, let's just do the very basic. Like, all right, how much value is transferred in this, like just in this transaction, right? And the first one, it says 1 ETH, and the value I see here is like 10 to the 18, basically, right? And you might be wondering, well, why is that? And the easiest reason is that you don't have decimals as a concept on chain, technically, right? Just because I can't remember the exact reason, but something about decimals makes the opcodes a lot harder to work with. So instead you have big ints, or like padding, basically. So everything is to 18 decimals by default, right? So if I wanted to get the actual values, I would divide it by 10 to the 18. And that'll give me like 1, right, for this column. Let's say I wanted to look at traces instead. Just gonna do this. So traces is what's executing kind of alongside a transaction. So some transactions don't have traces, some transactions do have traces. We'll get into this more when we look at actual smart contracts. As Adrian says, floating arithmetic, that's what they want to avoid. Yeah. I haven't gone that deep into the EVM, but I know there was something where it was like, this is a lot harder to do in EVM if you can't cut decimals. Yeah, you all are correct. So traces is more for technically when like contracts call other contracts. So like if I call a function a smart contract, I guess there technically is a trace for it. But most traces is like if I called Uniswap to swap something, and then Uniswap calls like USDC. Like let's say I was swapping USDC to ETH, then if I called Uniswap to swap, then Uniswap would call the USDC contract, and that would show up as a trace, right? And the only other thing but the main other thing that shows up as a trace is just the base call where you're transferring ETH value, right? So if I looked at this transaction hash, and remember, whenever you select a transaction hash or something from Etherscan, make sure you change this from 0x to /x, otherwise you're going to run into errors. So when I look here at this transaction on traces, I can see the value is also 1, right? But you have to remember, this value that's transferred in transactions here is only the value transferred from this signer to this to address, right? And sometimes you're calling like contracts like kind of like 3 levels deep that actually does the ETH transfer. And so that'll only show up in traces. That won't show up in transactions, right? So this first question is kind of asking you, all right, how do you calculate the difference between transactions block by block over the last week? So the easiest way we can do this, transactions, and let's just do block number, some value, and I will continue to use our left column method. Something else you should have on in Dune, if you don't already, is turn on the auto suggest. That'll make your life easier. So for those with less SQL experience, essentially what we're doing here is we're saying, hey, I want the total value transferred per block, right? So you say there's some basically there's something you're summing by, right? So in this case, we're summing over value by block number, and then you say just group by block number, right? You could add multiple things here if you wanted like both block number and like who sent that ETH, but we don't need that for now. All right, so I'm just taking the sum across both, and then select out from transaction value, and we should probably do a full outer join on traces value. If you aren't familiar with joins, they're a little more confusing, but essentially in this case I'm just saying I want a side-by-side of both the transactions and the traces by block. Alright, so I'm going to do on block equals trace on block. And here, let's take this one out. I know there's an error here, but we'll revisit here. We'll revisit it in a second. Here I'm just renaming the columns, otherwise it's just going to show up as sum. And if you hear squeaking in the background, that is my dog. Alright, so one other thing. I think, in the last week here, yeah. And the main reason for this is just because otherwise this query is just going to time out. So what you want is to filter on block time, right? And we want only the last week. So Postgres has a now function, so I can just say now minus an interval of 1 week, or you could put 7 days, or I can't do the math, but however many hours. I'm just going to put 7 days. Hopefully this runs quickly. I might have to do a lower interval, actually. For debugging, let's just go with the lower interval. Yeah, that's gonna take a while. Right, so why full outer join, right? So one of the reasons for that is like you might have a block that like had transaction, actually no, you can't have a block that had transaction value and no traces transferred, because if you transfer ETH, then there always is going to be a traces call for it. So actually, I can just do a left join. I was going to say you have to do a full outer join, and then you need something that's basically like a coalesce, but I don't think we need that complexity. So this looks right to me. And now we're just going to take the difference. Diff. Cool. So now we can see, like, block by block, what is the difference of traces over transactions of value transferred. And we're just going to use Dune's easy visualizations to basically say, all right, I just want to see the difference over time. And you can basically see by block, it's usually transactions that has a higher value than traces, right? So that means basically, well, not concretely, but basically people are transferring more from one address to another than like ETH transferred in just pure like contract to contract calls, essentially. And there's some of them with like huge differences. So you might see like, oh, there's a 7,000 ETH difference here. And it might be cool to then like dig into that and be like, okay, what's causing that difference? That should be a bonus question. I will add that as a bonus question. Let's see. I cannot read Markdown. Here we go. Largest. Right, so like one approach to that is just, all right, let's figure out what block number it was. So this is block 14,866,854. I'm not going to remember that. So let's just sort here. All right. So I'm going to comment this. And the easiest way of figuring out the difference is just order by. And I can see, essentially, someone transferred a ton of ETH. Huh. That doesn't add up. Okay, so this is why we dig into things. So we thought we saw 5,000 ETH difference, but that block only had a total of 535 ETH transferred, right? Which tells me I did something wrong. Alright, so let's take a look at that again. Oh, I'm dumb. I was looking at transactions, not traces. This is why we label things. Div. I should actually specify this in here. Traces. Because if you looked at only like which transactions, like why transactions had a higher difference, they're probably just going to find some whales that are transferring a ton of ETH. But if you look at traces difference, you can probably find something interesting at a contract level, right? So let's just do the same thing. I'm glad I didn't mess up that query. Wait, was I already something on traces? Okay, that looks right. So let's look at this again. Also, let me just check how many people we have on YouTube. Oh, okay, we have some friends. Nice. Cool. So let's order by value again. And we have 3 massive transfers of the same amount, right? So they're all in the same transaction hash. Let's see what happened here. This looks like a swap. swapping into DAI? No. Man, sometimes Etherscan is not fun to look at. Let's look at, what was the other site? Other site was Versatile. Let's just plug it in here. Oh, okay. This is a lot easier to look at. So who sent this? This is the from. This is the traces. That's not fun. I think this is just swapping into Lido, but I think I'm misinterpreting something here. Oh, swapping out of Lido is what this should be. Yeah, okay, yeah. We'll get into this more when we're looking at ERC20 contracts and whatnot, but basically, when I was looking here, it wasn't super clear what was going on. Like, I was pretty sure they were swapping from Lido to ETH, but using Versatile is a lot clearer in terms of, like, looking at the account balance differences. So I can easily just check through here and see, all right, they definitely had a decrease in Curve, and they had an increase in Ether, basically. And I'm not going to worry about everything in here. Well, this is interesting, actually. Null address went up and down. Wait, how does the null address go down in balances? I was going to say it went up in balances because... Oh, okay. So if the null address went up in balances, that means this much of the token was burned. And in this case, if it went down, that means that this much YWETH, the urine vault ETH, was minted, basically. Anyways, so that's just a fun way of seeing, like, okay, what was the highest in this case? And if you really wanted, you could dive deeper into, like, what calls exactly caused this. But we won't go that deep in this question. But yeah, that's the first one. I spent longer than that than I should have. All right, looking at question 2, and I'll save this. Let me just check YouTube to make sure I haven't lost. Shadow from Singapore. What's up, Jashawn? All right, question 2, looking at an example transaction. So I think for this one, we picked just one of the more complex swaps that we could find. Basically, we were trying to find a transaction with, yeah. So yeah, null address means minting or burning, right? So like anytime you mint a token, it's not like the null address itself can have an increase decrease. So, yeah, it comes down to how it decodes, but yeah. All right, I think my Wi-Fi cut out for a second there, but I think we're good now. All right, example transaction. So we're gonna look at this hash. It's 25 days ago. First thing, which I'm sure you all know how to do by now, is we want to go to the transactions table and just filter on where the hash equals this hash, all right? And if you're ever confused on what is available, then you should just be able to. Oh no, that's in V2. You'll kind of get used to what column headers are in here, but probably the main things that trip people up is like, oh, what is the column name for like either the transaction hash or the block time? Because like if you're using the transactions table, it's just hash. If you're using the traces table, it's transaction hash. If you were to use like any of these decoded tables, which we'll get into, then like if it's a call, then it becomes like call transaction hash, and if it's event, then it's event transaction hash. Same thing for like block time and whatnot, but you kind of get used to it. But you can just assume hash exists on every single table, right? Like hash is your main way of connecting across like all tables, or when I say connecting, I mean joining. So, all right. So we're looking at this. We have select all, well not select all, but we have select this hash from both, and we get only one transaction, which makes sense. You should only get one transaction. And for traces, we should get a ton. Yeah, 204 rows, right? So in this case, there's a couple of going about this when you see something this complicated. You could try to go through internal calls. Hold on, I have the wrong transaction. So you could try going through internal calls, and you'll see these kind of like basically a call type and then like a number. And essentially you can kind of think of this as like an ordering. So like let's say this is like delegate call. Here, let me do it this way. So in this case, right, we have delegate call 0 and then static call 0, 0. So it's like delegate call is happening at the top level, and then within the delegate call, there's a static call happening, as well as another delegate call, which is kicking off another static call, which is kicking off a delegate call. Right, so this was 0, this was 0, 0, basically the first thing to happen in 0, 0. This is 0, 1, which is the second thing to happen. And then you have 0, 1, 0, and 0, 1, 1, right? And you can see it keeps going. It goes like, how many levels deep is this? 3, 4, 5, 6, 7, 8, 9, 10, right? So basically what's happening is it all kind of rolls up in execution, right? So this happens and it waits for everything under it to finish kind of before moving on to like, I'm sure there's a 0, 2 in here somewhere. You go to the bottom, 0, 1. Here, I just want 0. I don't know if this is gonna work the way I want it to. I have 0, 1. I want 0, 0, 2. 0, 0, 0, 2. There isn't a 0, 0, 2. Okay, so sometimes there's another one after that. But yeah, anyways, that's just to kind of give you a sense of like, why are there so many calls? It's because, oh, I called one contract, right? So in this case, I called the Insta account v2 contract, right? And the function I called on it was cast. And cast basically then calls, let's see, basically makes this call and then a delegate call, which calls like a bunch of these other contracts that makes all of these kind of swaps across exchanges and like deposits and defaults and whatnot, right? But it's all chain calls, which is why you see so many of these, right? And sometimes the order doesn't really matter to you for your analysis, but sometimes it actually does. So it's just good to know like what are all these what all these numbers mean. And you'll see we basically have just 3 kind of main call types going on here. You have a delegate call, you got a static call, and then you have a normal call. Your normal call is kind of like the most basic one. So anytime you're transferring ETH from one address to another, that's a normal call. Anytime you're just calling a function, that's a normal call, right? Basically, calls saying, hey, this is something that's going to be able to modify memory or storage. And when I say modify memory or storage, that means like changing your ERC20 balances or changing your like Ether balances. That's going to show up in a call. If it's something that's not modifying storage, so it's like basically just like, oh, I want to get the allowance of ERC20 transfers between my address and a contract, then that'd be a static call because it's just retrieving data basically, and it's not modifying it. So that's static calls, just cheaper. And then you have delegate calls. Delegate calls are a specific type of like forwarding. You can kind of think of it as like email forwarding. So like I send an email to some like anon@gmail.com, and anon@gmail.com automatically forwards that email to like andrew@gmail.com, right? That's kind of what delegate call is essentially, but it's a lot more complex on chain, and it has to do with like gas saving and whatnot. But we'll probably cover